So today we will continue from the paper of 6/1/2025. Question number 3. Question 3 says student tests two solids, solid J and solid K. We have the solid J with the identity of lithium chloride. Record the expected observations. The student carries out a flame test on solid J. So state the color. Now, the color of the Bunsen burner flame when tested on the lithium chloride will give which kind of the color. To understand this thing, we must go to the qualitative notes at the end of the paper. And here we find the flame test for the metal ions. We can find the lithium ion, which is present in our compound J, will show the red color. So this will be your answer over here. It will be red. Then part 2. The student uses a roaring Bunsen burner flame to carry out the flame test. State why a yellow Bunsen burner flame is not suitable for the flame test. So as you remember from our previous question on the same topic related to the Bunsen burner, if this is the cylinder, metallic cylinder or the Bunsen burner with a flame coming out from here, there are two portions. This upper portion is basically a yellow color and the lower portion is sometimes it is said to be colorless, sometimes it is blue in color. The yellow color flame has low temperature and the lower portion has higher temperature. It is hotter portion. High temperature or it is hotter portion. So basically, the hotter portion at the bottom of the flame, it gives the correct observation of the metal ion in the flame. The yellow flame on the upper part is not that much hotter, so that does not give the correct indication of the flame color. So you will write this thing over here. The it is not hot enough, the yellow part of the Bunsen burner. You do not say yellow again because it's already there in the statement. You cannot write it again. It is not hot enough. So because of this reason, there's basically a very deep chemistry behind this temperature associated with the color. There is kind of electron excitation that then releases the energy, and that release of energy comes under the spectrum of the visible range, and that visible range is visible by our eyes. So there is a deep knowledge of chemistry behind this temperature with the color. So I'm not going into detail about that. At this moment, we can only tell that the yellow flame is not hot enough to provide the flame test. I hope it's clear to you, all of you. If you still have any question, you can send me a message. You can leave your message in the chat box. The part B, the student dissolves the remaining solid J in the distilled water to form the solution J. The student divides solution J into two portions. To the first portion of solution J, the student adds about 1 cm³ of the dilute nitric acid followed by a few drops of aqueous silver nitrate. Give the observations. So we remember J is a lithium chloride, and being a lithium chloride, you should remember that we are going to test the chloride in the compound J. To To check the identity of the chloride ion, we are performing the test with the dilute nitric acid along with that aqueous silver nitrate. So again, we need to go to the qualitative notes, and here we will see the test for the anion. In this part, we see chloride ions give a test with the dilute nitric acid along with the aqueous silver nitrate, and the test result is white PPT. So this is your answer, the formation of the white precipitate. White precipitates are formed. Then second part, to the second portion of solution J, the student adds aqueous sodium hydroxide until it is in excess. Give observations. The second test has been performed using the aqueous sodium hydroxide, and our compound is lithium chloride, LiCl. This is formula of the lithium chloride. So if the sodium hydroxide has been used, so let's see where they are using sodium hydroxide. In the part of the anion, we have chloride ion present, but in the test, you do not see anywhere mention of sodium hydroxide. There is no mention of sodium hydroxide in this part. So let's see about the lithium ion. In the cation part, we see there is no test of the sodium hydroxide with the lithium ion. Although there is a title of that, or there is a test of this aqueous sodium hydroxide, but there is no lithium ion in this whole list, which means you do not have any observations to tell. So in this case, what you will simply write that there is no change. No change. You cannot say there will be no reaction, but you will say there will be no change. That's what you will write here, no change. This is this is related with the observation, what you are looking at, what you are seeing during the reaction. You cannot say no reaction because there can be some sort of reaction, and it will maybe increase the temperature, decrease the temperature, or there will be some sort of smell produced, something like that. But you are not sensing that observation. So seeing is the observation here, seeing what you are looking at. So you are not looking at any change, so that's why you write the word no change. I hope it's clear to everyone. Then next, test on the solid K. Solid K. What we have in solid K? We have some tests performed on solid K along with the observations. Heat about half of the solid K in a boiling tube until there is no further change. Hold, hold anhydrous cobalt 2 chloride paper at the mouth of the boiling tube. So the observation of this test is condensation forms at the top of the boiling tube. So if condensation form means it is conversion from gas to liquid. You are looking at the droplets of water at the top of the boiling tube, at the edges of the boiling tube. This is a boiling tube. So droplets are found over here because of the condensation. And the second part of this test is you are using the anhydrous cobalt chloride paper. So this cobalt chloride paper turns from blue to pink. And you remember from the literature of the test we used, anhydrous chloride, cobalt chloride paper, COCl2.2H2O paper was used for testing the presence of the water. In the anhydrous form, it is blue in color. Without 2H2O, it is blue in color. And when there is a compound of water attached with the COCl2, it converts into COCl2.2H2O. And in this case, it is pink in color. So this was used to test the presence of the water. Okay. I will not go through these lines separately. I will just look at the question and then relate with the tests. C is a question. State the conclusion that can be made from the observation in test 1. So in test 1, we observed condensation occurring at the mouth of the test tube, and also the cobalt chloride paper is changing its color from blue to pink. So this shows the compound K is basically having water molecules bonded in the compound. In other words, it is basically the hydrated compound. It is the hydrated compound. And for this reason, when you heat it, the water are evaporated from the compound, and they are formed in the form of the droplets at the top of the boiling tube. So you will say compound K or solid K, because it is they are saying it as solid. So you can, instead of writing compound, you can say solid K is hydrated compound. Then D part, two different cations can give the observation test 2. Identify the two possible cations that the observation test 2 should show could be in solid K. Now let's look at test 2. Test 2, when performed, it was divided into 3 portions by dissolving into water. To the first portion of solution K, they added aqueous ammonia dropwise and then in excess. The results came out to be green precipitate forms. And after that, the precipitate remains when excess aqueous ammonia is added. So the test of aqueous ammonia has been performed on one of the portion of K. So green precipitates are formed which are insoluble when excess remains. The precipitate remains in excess means they are insoluble in excess ammonia. Insoluble in excess ammonia. So let's look at the qualitative notes to understand the identification. The aqueous ammonia test is there on the cations, and we have to look at the green precipitate. So green precipitates are mentioned here and also here. So green precipitates are present in these two ions, one in the iron 2 plus ion and the other one is chromium plus 3 ion. And both are insoluble in excess. This one is insoluble, this one is also insoluble. So this shows these two ions are present in the solid K. So we have inferred from this test the two possible cations present are Fe plus 2 and the other one is chromium plus 3, Cr plus 3. I hope it's clear to everyone. You can either write the symbol or you can write the names as well. Iron plus 2 is basically written as iron and then bracket with Roman number 2, and for chromium then bracket 3. The second part of this question, describe an additional test that can be carried out on solution K to confirm which of the two cations you have identified. D part 1 is in solid K. Explain how the result of this test shows which of these two cations is in solid K. Now, after looking at this answer, you are supposed to distinguish between these two ions. Which of these two ions will be present actually? Because this test of performing aqueous ammonia in test 2 did not help you to clearly distinguish between these two cations. So you need another test that can be used here. So for this purpose, you will again go back to the qualitative notes. So in front of the chromium ion and iron ions, you also have another test with the sodium hydroxide. So in this case, the green precipitate are formed with the chromium plus 3 ion, which are soluble in excess. However, with the iron 2 plus, if you perform the same test, you will find insoluble in excess. So this is the difference. These two are the differences between the two cations. It will be insoluble. This will be dissolved in excess amount. The precipitates, green precipitate will be dissolved in excess. But in case of iron 2 plus, they will be insoluble. They will not be dissolved. Along with that, you can also say that iron 2 plus turns brown on standing, or you can also say on leaving. That means you have the solution in the beaker or container whatsoever, and they are left as such. So after some time, they change their color. So iron 2 plus can be differentiated with the chromium plus 3 ion on these bases by reacting with the sodium hydroxide and leaving them out. The same test is also there in the title of the in the heading of the aqueous ammonia. It turns brown on standing or on leaving. So you can say that at excess, you write here, at excess sodium hydroxide. So explanation, we have seen that the iron plus 2 ions will be insoluble in excess, or green precipitate of iron plus 2 will be insoluble. Iron plus 2 green precipitate will be insoluble in excess ammonia. In excess sodium hydroxide, not ammonia. In excess sodium hydroxide, it will be insoluble. So this is how you can tell, or the other way is that you can add sodium hydroxide and leave to stand. For the other case, you can say and leave to stand. This part will be linked with its observation that it will change its color. The iron plus 2 ions will change its color from green precipitate to brown. Green precipitate will turn brown. So this part is linked with this part. So you have multiple ways to differentiate the iron plus 2 ion and chromium plus 3 ion. If it is still unclear, you can let me know. Okay, then E part, identify the gas given off in test 4. So in test 4, they have used sodium carbonate and effervescence is seen, which shows the gas is produced, and that gas turns lime water milky. I hope you are now familiar which kind of gas provides this result. You can give your answer in the chat box. Which gas is this one that turns lime water milky? Yes, students. Which gas turns lime water milky? Right. Others are not giving answers. Be active.
Dioxide.
Yes, carbon dioxide. So carbon dioxide is produced. Then identify the anion in solid K. Okay, so which anion is there? For this purpose, we need to also look at the test 3. The test 3 says when you add 1 cm cube of dilute nitric acid followed by a few drops of aqueous barium nitrate, a white precipitate is formed. So, which type of compound produces white precipitate upon adding barium nitrate? Which compound produces the white precipitate? Yes, anyone? We have performed this question before. When you add barium nitrate, then which compound produces white precipitate? It is BaSO4, barium sulfate. Remember this. BaSO4 always produces white precipitate, which means the solution K is having the sulfate ion present, because that sulfate ion, when reacted with the barium ion from the barium nitrate, they combine together. They combine together and they produce a barium sulfate, and that barium sulfate has the appearance of the white precipitate. So from this test 3, you are able to identify the anion present in the solution K. I hope it's clear to everyone. Sulfate ion is the anion present in the solution. Now, after that, question number 4. Question 4 says, when a solid metal is added to an aqueous salt of the less reactive metal, a reaction takes place. The reaction is exothermic and the temperature of the reaction mixture increases. The larger the difference in reactivity of the two metals, the, the more exothermic the reaction. So we have these multiple information mentioned here. Cobalt, manganese, and nickel are three metals which are all more reactive than copper and react with aqueous copper sulfate. The temperature of the reaction mixture increases during each reaction. Plan an investigation to find the order of reactivity to the three metals cobalt, manganese, and nickel. Your plan should include how you can use the results to find the order of reactivity of the three metals cobalt, manganese, and nickel. You are provided with the samples of cobalt, manganese, and nickel. So you have already studied this topic before in the topic of the metals, that one metal was more reactive with the other. There were three types of the metals: most reactive, and then we had the moderately reactive, and the other type was least reactive or unreactive. Least or unreactive type of the metals. Now here in this experiment, you are supposed to identify that these three metals, the copper, manganese, and nickel, these are more reactive than the copper. For this purpose, you can have only one observation, which is the temperature. The temperature of the reaction will tell you. So that means if the reaction is more reactive, then the temperature of the reaction will increase. For the more reactive or the most reactive will have the highest temperature, and the least reactive metal will have the least temperature. Noted. So how would you plan an experiment in which you can carry out the whole experiment, and along with that you have to also uh, you have to also note down the temperature change during the chemical reaction. So first of all, you will use the solutions of the copper sulfate here because it is a very abundantly available compound which you can use here. One copper sulfate, you will be using the copper sulfate in one beaker. Let's suppose a beaker with specified or known volume of copper sulfate. That volume should be same in all the experiment. It should not be changed. The volume of the copper sulfate solution should always be the same. Then you will measure a beaker with the specified volume of copper sulfate using the measuring cylinder or pipette. You have selected some fixed volume of the copper sulfate by noting the volume using the measuring cylinder or pipette, or it could also be the burette. Then, since it is asking or it is giving you the clue, the temperature change will be checked during the reaction, which means you must have one initial temperature and one final temperature. So at this moment, you will measure the initial temperature. Measure or note measure or note initial temperature of copper sulfate CuSO4. Now after noting the initial temperature, you will then add the compounds, the powder salts of the other metals in it, and they are, since in the powder form, powder samples of these three metals are to be added. So you must have the known mass of samples of metals. And now the names of these metals, and then add powder of metals in the copper sulfate solution. So definitely after adding, you have to make them react. For reaction, you need to stir or mix. Stir, mix the mix the solution so that the metals should properly react with the copper sulfate solution. After that, you will note the increase in temperature. There will be temperature increased, but you have only one way to tell the temperature is increased by using the thermometer. So note the temperature increase using thermometer. So after noting that, the most or the highest temperature increase will show the most reactive reaction between metal and the copper solution. So this is how you have noted which of the reaction is most reactive. Temperature by noting the temperature change. So we have completed this paper. If you have any question related to this paper of any part, please let me know.